Linux Application Programming Series Session 17, Editing with Stream Editor or SED. The name itself suggests that it is stream, meaning nothing is saved unless you direct yourself to a file. So whatever input you give, editing will happen as a stream. It will take the data from the file, it will edit it based on what you want to do with the data, and then it will display the data on the terminal. If you redirect it, then definitely you can send it to a file as well. So the agenda of the session is quick introduction to SED, discussion on spaces, typical command line options, regular expressions, numerical and pattern ranges, and most useful SED commands, day-to-day use commands in stream editor. Though it is a single command, but we are spending more time on it so that we understand features and options with SED with more examples. The SED is a stream editor that alters the text that flows through it using a number of types of transformations. SED does not alter the original file provided to it, but instead provides the transformed text to the standard output. So it's something like this. So you have original file, you have SED, a pipe, you allow some expressions, allow some modifications, you send the data to the file to it, and it will send the data as a stream. So original file will remain intact, and this is standard out where the data is displayed. SED is one of the oldest tools in UNIX, written in early 70s by Lee McMahon. What a name. SED operations are stream operations where simple scripts provide filtering and transformation of the text. Quite logically, that whatever comes to this editor, we apply the filter criteria that filter those lines which are matching this criteria and apply this transformation on them, and the transformed text is sent to this. In between, there's something more which can happen here, and that's what we are going to discuss. What is the staging area, what this area offers. So we send an input file, the stream editor. For example, this is a command s/is/uppercase is/g in single quote. So what is the meaning of s, what these slashes are, what this /g is? Let's wait and watch. Output will be in standard output, the modified version of the file with this expression or change or the command of SED. Let's understand this command itself, what was the given in this slide. So we use SED command, then s/is/uppercase is/g. The G stands for global. This is a replacement string. This is original string, pattern string, or search string, or matched string. And S stands for substitute. This is also a command. So substitute lowercase s with uppercase S globally in this file and display the modified content as a standard output. That is the understanding of this command. We invoke SED using SED and then provide a script to use on the input file, the file.txt, for example. The SED script represents a substitute transformation where a pattern is searched in the input stream and when found is replaced by the replacement string. The command or commands pattern string and replacement string are delimited by /. This character can be used for search and replace. I'm talking about the S character which was given in the command. Substitute. We end our SED with small g to indicate that we wish to perform the search and replace over the entire string. If the G character command were not used or were not provided, only the first occurrence would be replaced. We could instead replace G with a number which could indicate the particular occurrence of a change, like third occurrence, second occurrence, fifth occurrence, or what. For example, you could have provided /G, /2, to indicate that you want to change only the second occurrence of the matching string. This is a simple script. To complete our introduction, let's look at a script in action on the file.txt, and the file has this content. This is a simple text string which is going to be used, then blank line. This is one more string that can be used. Finally, this is the last string in the test set. Now we use our previous SED script for this file. So what do you expect as an output if we apply this? So since we used global, so every occurrence of is converted to uppercase wherever it is. So that's the SED, power of SED. That's what it can do. Each occurrence of small is replaced with is, uppercase is, over the entire file. If we omit this final flag G, then you will see the output as first occurrence is replaced, not rest of the appearances. Only first occurrence in every line, not rest of the occurrences. Rest all are not replaced, only the first occurrence in the search pattern is replaced. Not in the file, in the line. It is applicable for line. So first occurrence of every line is replaced. We can create two transforms by using -e, like SED -e, substitute small s with uppercase is, small uppercase is for small is file.txt. So resultant will be what? Original file. So if you try with this, the file will be same file as it is, no change, because you are reversing your previous transformation in the second one. In this case, we convert to uppercase and then we follow this in reverse transformation. The result will be same as the original file. The key here is the use of -e, which is script or expression, to provide multiple transformations on the same input text. SED spaces or buffers, that makes it more powerful, because with SED spaces or buffers, what we do is we hold some data in buffer and then we continue searching. Then we use our pull back our data, like the concept of variables. We hold the value temporarily in a variable, then we use another value, we pull back old file, old value, then we change it. So buffers play a very vital role in SED, because they gives you more power to process or transform the data from the files. Within SED, there are a number of spaces or buffers on which SED command operate. Each input line is copied to the pattern space. The pattern space is the temporary holding space on which SED commands are performed. Once the provided SED script have all scripts have all been performed on the pattern space, the line is copied to the output. There are also hold space within SED we can copy the contents of the pattern space to the hold space and then retrieve them at a later time, and that's what I was suggesting, that you can have a temporary storage of the content so that you pull back that at later stage and then process it in continuation along with the new text. The hold space is just a temporary buffer, but it can be useful to remember certain lines to be processed along with other lines. Command line options for SED. The SED script can also be specified in a file. This can be useful when complex SED scripts are needed. To invoke a scripted file with SED, you can use -f, and that make it much more powerful. Just like awk, which we are going to discuss tomorrow, you can put your content, put your command transformations in a script file and then invoke that SED with that file name with -f option to specify the script file. We can suppress automatic emission of SED output by using -n flag. When dealing with a very large file, we can achieve better intermediate performance with -u flag. In this unbuffered mode, SED loads smaller amount of data from input file and flushed data to the output file more often, means less memory will be consumed. This means better visual performance, but may represent worse overall performance depending on what you are doing. So regular expressions, as those who are new to regular expressions, I'll start with a simple example of 1 minute. The example is, suppose you have a text file which have maybe 1000 pages, and if I ask you to scan the file, parse the file and display all the email addresses from the file. Now I request that yes, my requirement that you parse the file and fetch all the email addresses, and remember they are scattered. This is a continued text file, so there is no specific thing where email could be. Every page may have 1 or 2 or 5 or 10 email addresses. So what would you do? First you will make a pattern which represent an email address, and then you use this stream editor concept or awk filter or grab command to find out all the lines that match the pattern. So you need to understand that pattern, that basically is known as regular expression. Regular expression use 3 constructs, or 3, in a way we call them as form of expressions or character classes, like qualifier, anchor, and one more. Let me recollect myself. Anchor, word boundary, and quantifiers, I think that's what it is. But let me explain that. For example, if you use /d, this is exact match. Matches any occurrence of the word dog. This is called character class. Within square bracket, if you specify any character, list of characters or range of characters, then any single character from that will be considered and will be taken as yes, it is there. Remember -a to z, if it is used, it will include all the lowercase letters, but z to a will not be allowed. In that case it will match 3 characters, any 3 characters, either z or hyphen or a. This means those will be treated as separate characters. So reverse order is not allowed, only increasing order is allowed. A to z single character small letters, A to Z any single character uppercase or small case, 0 to 9 single digit. 0 AB1 means first 0 and then either A or B and then 1. That means 0A1 or 0B1. Z star means any character 0 or more occurrences of Z. 0 occurrence means no Z. And even if it is 5, then 5Z. Remember one thing about regular expressions, they are greedy. That means if it can match first 10 characters and it can also match first 15, so it will display first 15. It will continue matching as long as it can match. They are greedy in nature. That's the behavior of this regular expressions. Z question mark means 0 or 1 occurrence of the previous character, that means 0 or 1 Z. Negation is given by caret symbol, that means not 0 to 9 means no digit. However, this caret symbol, it appears anywhere in between, that will be taken as a literal single character caret symbol. So only beginning have a special meaning. Apart from beginning, if this character appear anywhere else, that will be taken as single character itself. T.M, T followed by any character, dot means single character. Any single character in between T and M means Tom, Tam, Tim, anything. Regular expressions. The square bracket indicate range of characters. I already explained that. Star means 0 or more characters. Question mark 1 or 0. Caret symbol, character that are not given in the match in square bracket. It is used in square bracket, not outside that. Dot means any single character. Other two regular expression called anchors. Anchors means where we define the boundaries. Line beginning with, line ending with. So beginning with is defined by caret symbol, not in square bracket now. This caret symbol is outside square bracket. The meaning is different. Outside square bracket, caret symbol signifies the beginning of the line and dollar signifies the end of the line. Ranges of occurrences. The range of line can be processed by SED that can be restricted using ranges. A line range can consist of a single line definition or a range of lines. Like 5S means this talks about the 5 lines. Substitute this into that. So this replaces occurrences of this line with that of line 5. On line 5. So on line 5, this will be replaced with that, because we are talking about line number 5. We would specify that only the first 5 lines are operated. Then what we do, we specified 1, 5. That is range is given, where 1 to 5 represent the range of lines 1 through 5. If instead we wanted to range of line 5 to the end of the file, we could provide the dollar sign. Then expression would be 5, $, because dollar represent the end. 5, $, S. So this and that. Ranges and occurrences. The exclamation mark tell SED not to apply to the given range. That means negation or exception. That can also be done. And this is negation. Don't do this from line number 5 to end of the file. So that means indirectly we are saying do it from 1 to 4. This tells SED to apply the substitution to all line excluding line 5 through end of the file. Indirectly 1 to 4 only. Rather than specify the line ranges, we can also define ranges based on patterns. And this is where the pattern regular expressions we discussed will help you to specify. Now understand this. Caret symbol, THA. Learn to read the regular expression. How we read it? We read it beginning of the line followed by uppercase T followed by H followed by E. No more condition. That means we are not specifying how many characters or what else can be there in the file. We are not talking about that this line should have only one word. It may be anything else, but we are talking about only first 3 characters, and that also right in the beginning of the line, because we are reading it like beginning of the line followed by uppercase T followed by H followed by E, and not bothered about what after that is coming. So this substitute that for this for any line that begins with uppercase THE. We can also perform substitution between pattern ranges. Now it will become much more easier. So this is start pattern, this is end pattern. That can be done. So you specify two patterns separated by comma, you put them into braces. I mean that regular expression can be given here. So this replaces index IDX after a line that contains start, because we are giving the literal string. Regular expression could have been given, but we are giving a literal here. Start and the is found and ends with the replacement after the line containing end is found. Essential SED commands. So now, after going through few examples, let's understand these commands one by one. We have talked about only one command so far, that was S, that is substitute. But there are more commands, like we have change, delete, substitute. So let's understand the commands one by one. Substitute. This is what we have studied with example. It provides a simple search and replacement over the input stream. Like address, this is address 1 is mandatory. Optionally you can specify where to end, where to terminate. And substitute, what you want to search and what you want to replace with, and globally or specific line number, I mean specific occurrence in the same line. An optional address or address range can be specified before the substitute command. That's what we specified, because this everything is substitute. This is optional. A square bracket itself, in any syntax the square bracket represent optional. So first entire thing is optional, then if you specify this, then this is optional, which essentially means you can specify only address 1, or you can specify address 1 and address 2 both, or you can ignore both of them. A single address indicates that the substitution is restricted to particular line or search expression. Two addresses or patterns separated by comma indicate the range for the substitution. The flags are N, that representing the line number, and G representing the global. If a number is specified, the substitution is performed only on that occurrence in the line, like fifth occurrence in the line, second occurrence in the line, first occurrence in the line. G means all occurrences in the line. We have seen that example. Like this, that, we do not specify anything. So this will by default replace only the first occurrence. Substitute command continued. We could achieve the same thing with the script, this, that, and we specify which occurrence you want to change, and we specified 1. If we wanted the second occurrence of this to replace with that, we would have simply specify n as 2, that means /2. The global flag specifies that all occurrences on the input lines will be replaced. Next command is D. This delete the command simply delete the line that matches our defined restriction. Now look at the use case. You want to remove certain lines from the file. Okay, let me put it that way. In Linux, all the configuration files are stored into etc folder. Almost all configuration files have comments. I want you to, if I say I want you to remove all the comments and keep only the meaningful lines. So what would you do? You will find all the lines that begin with hash that contain the comment, and you will remove those lines, delete those lines, and then by default it will display that into standard output, and instead of standard output you can replace that in the same file. So that will replace the file. That way you can do some changes, delete some lines, like delete all the blank lines, delete all the lines that are matching with this. So that SED is very powerful. In fact, we used it in our one of the script, I recollect. We used it and somebody asked me to explain that, and I provided additional document for that purpose, if I'm correct. Not document, but I explained that I modified that slide. That was where the SED was used, stream editor was used for modification. So substitution was used in that example, I believe. For example, and that was makefile, dependencies related makefile, if you recollect, the last slide almost in the makefile. For example, if we wanted to remove the first 5 lines of a file, we could use this simple SED command. SED 1,5 means delete 1 to 5 file.txt. Now one thing don't forget, it is not actually delete from the file. It will delete and then display the output in the standard output. It will not replace the content of the file. It will not change the file in place. We could tell SED to delete all but the first 5 lines using delete command, reversing the restriction with exclamation mark, negation. That can be done. So we have understood that also. Then we have the print command, P. The print command can be thought of as a reverse of delete. One difference is that we must specify -n flag to avoid double printing the output. To reproduce our earlier delete example, emitting only the first 5 lines, we could use -n 1 to 5 file.txt, so it will print first to 5 lines of the file, not rest of the lines. We could also instruct SED to emit only those lines that contain a particular such string, such as those containing a colon at the beginning of the line, like this, line beginning with, you remember that regular expression, line beginning with colon, and then print those lines. Appending A, inserting I and changing C. These are single character other commands, A, I and C commands. To insert a blank line after a line is found containing start, you can use this start, the line where we have the start word, and then we want to insert a blank line, so we can use A. So a blank line will be inserted immediately after the line that begins with start. We could insert a blank line at the end of the file using insert command. So dollar means at the end of the file, you know that, end marker, I for insert, and then blank, the file.txt. We can change a line entirely by using C. The script looks for the word secret, replace the entire line with deleted. Verified script, line file 4 is there in your directory, and you can try this command secret/c change, and change this word, wherever the word secret is coming, change that line to deleted and in the file. So try this on file 4, the file is given to you. Finally, we can perform all 3 commands using curly braces symbol to group the commands. The following script will emit a start line before the line matching the keyword, a stop line after matching the line, and then emit a deleted line for the line itself. All the 3 commands will be grouped together, and that is where we can write the script. So SED, then we continue writing the script, single quote started, secret, and all the commands are grouped together with curly braces. Curly braces, I start, A and C deleted, means insert where the line have the start, append where the line have end, and change the line that deleted. Right? This will be done in file 4. You can try on the same. I have verified this, and this is the screenshot of that. This is a simple file string which is going to be used. One more string that can be used, start, deleted, end. So I use the word start, insert this line that have the start, and delete, and the deleted word is inserted the line that have the matching string. because we are searching for the string which have secret. All these commands are applied before that. So before secret, insert start. So a line is inserted, start is written. After that word, secret, then the end, and the line which have the word secret, replace that with deleted. That's very interesting example. Then we have quit. Quit command is same as name applies, simply end the SED session. This command can be quite useful, like 10q file.txt. This command print first 10 lines of the file.txt. When the 10th line is reached, the SED command simply quit. This particular command emulates another useful UNIX command called head command. Yes. Then we have transform command called Y, transformation. We can transform text using the Y command. This provides for replacing one character for another. We provide two sets of characters. The first refer to the search set and second the replacement set. For example, if we encounter uppercase A, we want to replace with small a and so on. In that case, you have to specify exactly same number of characters for search and equal number of characters for replace. Like here, if you specify 10 characters, here also you have to specify 10 characters. So first will be replaced with first, second will be replaced with second, third will be replaced with third, and so on and so forth. So to convert all uppercase letter to lowercase, this is a very good example. First 26 characters in small letter, next same 26 letters in uppercase. So small letters uppercase, in other words, this is doing what? Converting uppercase letters to small case. The pattern and replacement string represent a 1-to-1 correspondence, as I said very clearly, for each character. For this reason, each string must be equal in length. Then we have line numbering, equal sign. Equals command is used to emit the current line number. This can be used to emit the line numbers that match a given search string, or to simply emit the number of lines in the input file. For example, if we are interested in which line contains a given search pattern, we could accomplish this with this simple SED script. So -n, this equals, which means search the word this and display the line number of that. This script results in the line number emitted, one per line for each line that contains the word this. This is a very good example of holding pattern space. Using the hold buffer, we can store away the pattern space to hold buffer and then operate on the pattern buffer directly. Now look at this example. SED, store the pattern space to the hold buffer with H command. We continued. Perform the substitution on the pattern space, that is substitute. Append the unaltered line to the pattern space, that is G, and then in the file.txt. So this is what you will getting. So you are getting the replacement and original both. The following example print both altered line and unaltered line, changed or unchanged, original line and changed line. Also known as shown here are the commands within SED script. All characters after the hash symbol are the commands, actually what they are doing. So this is the same command. Store the pattern space to the hold buffer. H, perform the substitution, and then append the unaltered line to the pattern space. The script will emit altered line and follow it immediately with the unaltered line, the line not having been altered by the substitute command. So summary. While we have only scratched the surface of text processing with SED, correct, this is right statement. I can spend, because there was one training I delivered and 4 lectures on SED, not a single lecture. So this is right to say that we have scratched the surface of text processing with SED. In this short introduction, we have seen some of the power provided by this little utility. We took a quick tour of regular expressions and their use in SED, as well as the use of numerical and pattern-based ranges to restrict SED's processing. Then we reviewed some of the most used SED commands, including substitution, printing, deleting, and transforming. These are simple, some of the one-liners, like display first 10 lines of the file, like head command. Emit double-spaced version of the file, SED uppercase G. Emit number of lines in input file. Emit the last line of the file. All lines greater than 30 characters in length. Non-blank lines. Remove all blank line at the top of the file. So these are some of the example, we call them as one-line.